What is simple linear regression? Explain. Okay, a simple linear regression is an equation that represents a line that represents our data. So for example, we have a plot of data here, a pretty strong positive relationship here. Now, simple linear regression fixes a line to the data. You may have heard the word trend line before. That's what this line is. It is the simple linear regression line. And what it does is it fits the line to the data so that there's pretty much an equal distance between all of these dots from above and below. We can use this equation to predict values maybe out in here, like we did in the crocodile one. So our normal crocodile data only went to a certain amount of head size, but we wanted to predict it for a head size that we found that was way bigger. So we can come out to here. Now with the data alone, we only get to this first x, okay? But if we can fit a line to it, and if that continues on, we can predict the line out farther and use that to predict a body length that correlates with this larger head size. So that's what a simple linear regression is. Question 2. What is the formula in the online textbook in terms of y hat, b naught, b1, and x, which represents the linear equation used to estimate a line relating the variables x and y, assuming a linear relationship exists between these two variables? Okay, so our equation is going to look something like this. We have our y hat is equal to our b naught plus b1 times our x. Okay, this is very similar, if you'll remember back to your algebra, this is very similar to the y equals mx plus b. Okay, but we've switched these two around. So we now have our y-intercept first. So y-intercept is our b naught, and our b1 is the slope. So if we come back one more time to the crocodile example, our y hat is our response variable, or what we're trying to predict. So in that case, it would be the body length. And your x would be your explanatory or your head length. So that's your equation. Question 3. Find the line y equals 1.34 minus 2.2x. What is the slope? Okay, so the slope for this equation, let's write out the equation first. Y is equal to 1.34 minus 2.2 times x. Okay, so remember our slope is this point right there. We have our b naught, which is our y-intercept, and then we have our b1, which is our slope. Okay, so it's negative 2.21. Question 4. Find the line. What is the y-intercept? Okay, so the y-intercept for question 4 in the same equation is the first number. Okay, so it goes y-intercept and then your slope times your explanatory variable. Question 5. Using the prediction line above in question 4, predict the value of y for the given input value of x equals 5. Okay, so now we have our equation and we know what each of the variables mean. We have our y-intercept, and then we have our negative slope, our negative 2.2 slope, times our explanatory variable. So they want to know what is the response, the predicted response, when given an explanatory point of 5. Okay? So in order to find that out, we just put it through just type that into your calculator, 1.34 minus 2.2 times 5. and you come out with negative 9.66. What is the explanatory variable? Okay, the explanatory variable is the head length. Remember, the explanatory is what we're given, what we want to use to predict something else. Okay. Question 2 is what is the response variable? The response variable is what we want to predict. So in this case, we're given the head length and we want to predict the body length. Okay? So body length becomes our response variable. What is the equation for the linear regression line? Well, the equation, we're going to use the values we just gathered. So we got our y hat, which remember represents our body length. It's equal to negative 69.369 plus our slope, which is 7.4 times x. X is our explanatory variable. Remember, this is our y-intercept, and this is our slope. Question 9. Use the regression line you obtained in question 6 above to predict the body length based on a head length of 51. Okay, so this time, we're going to use our equation that we have to find that. So in this case, our explanatory variable, which remember is x, or the head length, is 51. Okay? So then we can just use this equation, the equation that we found in the previous problem, to find the predicted y hat, which remember y hat in this case represents body length, by just typing this into the calculator. And when you type that in, you get 308. Why are the values for question 8 and 9 different? Well, if we think about it visually, on our chart, on our scatter plot, we have all of our data right here, okay? And that's where the original question 8 came from. It said find the crocodile that has 51. So let's say that 51 was right here. Okay, so 51 is this dot right there. Okay, and that dot corresponds to a body length of 343. Now when we do our predicted, that comes from the trend line, which we add, which represents the average of all of them. Okay, now when we go to 51 on the predicted, we're a little bit lower, down at 308. Okay, so there's obviously a gap between what's predicted and what we actually observed. That's why they're different. 3 asks you to create a scatter plot. Okay, so we're going to copy and paste our data over. So we're going to use our head length, remember, as our explanatory variable, because that's what we're given. We're going to paste that into the explanatory variable. And then we're going to take our body length and copy the body length into the response variable. Now remember that we're doing this all in the quantitative inference procedure Excel sheet under the linear regression link page down here at the bottom. Okay? Now, question 3 asks for the scatter plot, which is given right here in the bottom right-hand corner of your Excel sheet. Question 4, use the software to compute the value of the y-intercept in the regression line. Okay, so the y-intercept, remember, well, first off, it's labeled right here as the b0 is given as negative 69.369. Okay, so your b0 is your y-intercept. Question 5, use the software to compute the slope of the regression line. And the slope is given in the line right below. The slope is 7.4. Okay, question number 7 asks us to put a trend line in our scatter plot. So you can do that very easily by clicking on any one of the data points, right-click it, and come to the bottom where it says Add Trend Line. And you'll have a bunch of options, but for simple, we always want it to be a linear line. So linear, close, and there is your simple linear regression trend line. Question 8, also on Excel. Question 8 asks us to find the head length, or the body length, with a given head length of 51. So we can just come back here to our data and look for a 51, which can be found right there. So we have, with a head length of 51, we've had an observed of 343. Okay, if we open up our Garian crocodile data, we're going to create a scatter plot to represent the head length and the body length. And so in order to do that, we come up to Graphs, Legacy Dialog. We have to have a scatter plot. It's going to be a simple scatter plot. Okay, and our head length, remember, is our x-axis, which is what we're going to use to predict the y-axis, which is our body length. Okay, and if we come up here to, okay, we don't need any of that, so we can just use our y and our x-axis to use our line. There is our scatter plot. Question 4 says, use the software to compute the value of the y-intercept in the regression line. Okay, so we're going to come back to our data, and we're going to analyze and regression, which is right here, a linear regression. Okay, and our independent is the head, and our dependent is the body, because we're saying that the head, whatever size the head is, the body is dependent upon it. Okay, and if you hit, that should be good for this instance. Okay, so we are going to hit OK. If we come back to here, we can see that our value is right there. The constant, the y-intercept, is the negative 69.369. Question 5, use the software to compute the slope of the regression line. The slope is the second row, which is head length, 7.4. Use the software to draw the regression lines on the scatter plot. Insert the picture of scatter plot with graph of the regression line superimposed over the data. Okay, so in order to do that, we've got to come back to our data. We're going to graph, legacy dialog, and a scatter plot. It's going to be a simple scatter plot. Okay, remember this is the same thing that we've done before, so we can move our head length into the x-axis and our body length into the y-axis. And we have our scatter plot. If we double-click on that scatter plot and click Elements, and then hit Fit Line at Total, and that'll give us our trend line. And it also, you can notice, gives us the equation of our simple linear regression, which was your previous question. For the observed head length of 51, what is the observed body length? Okay, so we come back to our data that was given, and we look for one that has 51. There it is right there. Okay, so with an observed 51, we had one crocodile that had a head of 51 centimeters and a body of 343. Question 9. Use the regression line you obtained in question 6 above to predict the body length based on a head length of 51. Okay, so this time we're going to use our equation that we have to find that. So in this case, our explanatory variable, which remember is x, or the head length, is 51. Okay? So then we can just use this equation, the equation that we found in the previous problem, to find the predicted y hat, which remember y hat in this case represents body length, by just typing this into the calculator. And when you type that in, you get 308. Or I'll show you real quick how to do that on SPSS directly. So you type in the data, the value that you want to predict, and then you come up here to Analyze, Regression, Linear, Our head and our body are already in their right places. We come to save, and then check the unstandardized predicted values. What that's going to do is it's going to place in our data another column called pre-1, which represents predicted values. Okay? And then if we come over here to the row in which we typed in the one that we wanted to find, we got 51, okay, which was 308.03, which is exactly what you would have gotten if you would have plugged it into your calculator using the equation.